In many situations, equations won't be set up in such a way that you can immediately use the zero product principle. Luckily, it's not too hard to get it into that form. We always want to make sure we have 0 on one side of the equation. We can often use a little bit of algebra to just move terms around. The second thing is that we need to factor the side that 0 is not on. So this is why we spent all the time on factoring. After that, once we have one side factored and 0 on the other, we can use the zero product principle to set each factor equal to 0 and solve these easier equations. And then, of course, we always want to check our solutions. So let's take a look at a couple of examples. X squared minus 5x minus 6 equals 0. We've got 0 on one side, which is our first step, so that's good. We want the other side to be factored. Right now it's not. It's a trinomial multiplied out. We want it in factored form. So let's factor it. A trinomial will factor into the product of two binomials, so you can set up your parentheses. X squared goes to x and x. And then we've got a negative 6 as a constant term. We want to factor that to find a two factors of pair that will add up to negative 5. Because negative 6 is a negative, we want to use one of each sign. So negative 1 and 6 or negative 2 and 3. The one that is going to add up to 5 is this one, but we want a negative 5, so switch the signs. So I'm going to use a plus 1 and a minus 6 here. Double check your factorization. Take 10 seconds or 20 seconds to just double check it before we go on. It'll save time if you fix any mistakes then. Once you know it's good, go ahead and take advantage of the zero product principle to set each factor that you have there equal to 0. So x plus 1 equals 0, x minus 6 equals 0. Solving these simpler equations, we get x equals negative 1, and we get x equals 6. So it looks like we have two solutions. We should always check them to confirm. So if I start with the first one of negative 1, I want to take negative 1 and always put it back in the original equation, not anything you have later, what you started with. So negative 1 quantity squared minus 5 times negative 1 minus 6, is that 0? So we're going to check to see if that's true. Go ahead and multiply, add these out. So negative 1 squared is positive 1. Negative 5 times negative 1 is positive 5 minus 6. 1 plus 5 is 6, minus 6 is 0. So that one checks. The second one, put a 6 in. 6 squared minus 5 times 6 minus 6, is that equal to 0? Multiply out, 36 minus 30 minus 6. Looking good here, 36 minus 30 is 6, 6 minus 6 is 0. There we have a true statement. So both of these solutions worked. Often you'll have an instructor like me or another instructor ask you to write out solutions in a sentence. If you're asked to do that, there's two common ways you can do that. I could just literally say the solutions, plural, because there are two, are negative 1 and 6. Or you can phrase the sentence with us talking about it as a solution set. The solution set, so when we talk about a set, we're talking about a single set, is, and then we use braces to say negative 1 comma 6. The brace is telling you that you're looking at individual values. So there are two solutions in the set, negative 1 and 6. So those are two common ways you can write out an answer to an equation when you're finding solutions. The second example we have, 2m squared equals 5m, does not have 0 on one side. So the first step is to get 0 on one side. One hint, it's always better to keep your variable that's squared, in this case m squared, positive. And since it's currently positive, I'm going to choose to move the 5m to the other side of the equation. To do that, right now 5m is positive. To move it over, I want to subtract it from both sides, so it's going to be negative when I move it over. So I'm going to have 2m squared minus 5m. Always write these terms when you move something over in descending order. We're used to factoring that way, so it's a good idea to write them that way as you move things. This is a binomial that we want to factor. Remember, to factor binomials, the first step is always look for something common. The m is common, so we'll take it out and in parentheses leave what's left, which would be 2m minus 5. Take a moment to double check that you factored correctly. So multiply back through. M times 2m is 2m squared. M times negative 5 is negative 5m. If you take just a couple of seconds to check before you go on, sometimes you'll save yourself a lot of grief. All right, now we have a product equal to 0, so I can set each factor equal to 0. Immediately with the first factor, m equals 0, we've got a solution. The second one, we're going to still have to solve. 2m minus 5 equals 0. We're going to need to add the 5 to both sides, then divide out the 2. And there we have m by itself. So these, it looks like, are two solutions again. Check them both. Plug 0 back in again to the original equation. So 2 times 0 squared equals 5 times 0. Pretty much what we have is 0 times anything is 0. 0 times anything is 0. So that one checks rather quickly. The second one, 5 halves is a fraction. That may take a little bit more effort. 2 times 5 halves squared equals 5 times 5 halves. Little reminder when working with fractions and order of operations, you should always square first. When you square both the numerator and the denominator. And then when you're multiplying with fractions, you think about any whole number as being over 1 and you multiply straight across. So 25 over 2. On the other side, 2 over 1. So again, we get, in this case, 50 over 4. But remember, with fractions, you can cross cancel when you're multiplying. So 2 goes into itself once and into 4 twice. So really what we have here is 25 halves on both sides. So we have both of these solutions checking. So once again, I have two solutions. I could just say the solutions are 0 and 5 halves. Here are two more equations for us to solve. We're going to again use these 4 rules. So let's first get 0 on one side, then factor the other side. Looking at our first example, we have the quantity a minus 3 times the other quantity a plus 8 to give us 30. So this is equal to negative 30. We have a factorization on the left, but we do not have 0 on the right. You must have 0 on one side of the equation as your first step. Because we don't, this factorization is meaningless. So to actually move the 30 over, we're going to need to multiply that out. So a squared, when we FOIL, plus 8a minus 3a minus 24 equals negative 30. So that factorization is useless without having 0 on one side. Now we're going to move this 30 over. When we move it over, because it was a negative 30, it's going to become a positive 30. Let's collect like terms at the same time. A squared plus, these become 5a. And then minus 24 plus 30 is going to give me plus 6. Now we have 0 on one side, which is our first step here. Next, we are going to factor what's left on the left. So when I factor this, a squared plus 5a plus 6 equals 0. We're going to factor the a squares to a, and then 6, we could factor two ways, 1 and 6, or 2 and 3. 2 and 3 add up to 5, so I'll use the 2 and the 3. And then we can set each factor equal to 0 because we now have a product equal to 0. So we get two simpler equations, a plus 2 equals 0, or a plus 3 equals 0. Solving each of them, we get a equals negative 2 and a equals negative 3. Two solutions we can check. Remember to check in the original equation. Always go back to the original equation. So what we have here is negative 2 minus 3 in parentheses, negative 2 plus 8 in parentheses equals negative 30. Calculate both sides. We have negative 5 times positive 6. A negative 5 times a positive 6 is a negative 30, so that first solution of negative 2 does check. Our second solution of negative 3, plug that in. Negative 3 minus 3 in parentheses, negative 3 plus 8 in the other parentheses equals negative 30. Order of operations, negative 6 in the first parentheses, positive 5 in the second. Negative 6 times positive 5 is negative 30. That checks as well. So we do have two solutions that work. We could go ahead and phrase that as the solution, I should say plural, solutions are negative 2 and negative 3. And our next equation, we do have 0 on one side, so that's the good news. Our other side is y cubed plus 2y squared minus 3y. It's a trinomial, and we can factor it as we would factor trinomials, but let's take a step back. Remember, in any factoring situation, you should always look for something common first. And I see lots of y's here. In fact, there's at least one y in every term. So your first step should be to take that y out. So take it out of every term. So when I take it out of the first term, I get y squared, second term plus 2y, and the third term minus 3 equals 0. Now, the y on the outside is a factor, but we still have a trinomial left here on the inside of the parentheses that we can continue to factor because the y is squared. So a trinomial will factor to two binomials. Set up your parentheses. Y squared factors to y and y. The negative 3 that we have here factors to negative 1 and positive 3. Those will add up to positive 2, so I can put those in as y minus 1 and y plus 3. In this situation, we have, it turns out, 3 factors multiplied to give us 0. Y times y minus 1 times y plus 3 equals 0. So we're going to set 3 factors equal to 0. Y equals 0, which is actually its own solution. Y minus 1 equals 0, which we can solve and get y equals 1. Y plus 3 equals 0. And we get y equals negative 3. So we end up with 3 solutions, and if you look carefully, where we started was with a y cubed. You'll tend to see this pattern that cubic equations often have 3 solutions, whereas quadratic equations, like our last one, often have 2 solutions. Notice I'm saying often. They don't have to have that many, but they can have that many, and you will typically see that many. Now, we do need to check each of these 3 solutions. So I'll check the 0 first. Always go to the original equation. 0 cubed plus 2 times 0 squared minus 3 times 0. Is that equal to 0? Well, 0 plus 0 minus 0 is 0. So that one checks pretty quickly. The second solution, the 1, plug that in. 1 cubed plus 2 times 1 squared minus 3 times 1. Is that equal to 0? Well, I get 1 plus, well, 1 squared is 1 plus, times 2 is 2, minus 3. That looks like 3 minus 3, or 0, equals 0. So that one checks. And our last one, plug in a negative 3. So negative 3 cubed plus 2 times negative 3 squared minus 3 times negative 3, is that equal to 0? This one, there's a little more calculation to do. Negative 27 plus, this is going to be negative 3 squared is 9. 9 times 2 is 18. Negative 3 times negative 3 is a positive 9. I'm running a little bit out of room, but negative 27 plus 18 and 9 is 27. So negative 27 plus 27 is going to be 0 equals 0. That also checks. So again, we end up with 3 solutions here. The solutions to this last equation are 0, 1, and negative 3.